Hello, my viewers and my dear learners. This is your DK Misra, sir. I welcome you to this session. Good morning, good afternoon, good evening, whatever you are connected with. So, today's topic is polynomials. It is very important. So, this is class 10, chapter 2, polynomials. We shall discuss in this session. Now, as you know very well, and you are familiar about that, in class 9 we have studied about polynomial in one variable and the various terms degree zeros of polynomial. We have learned that only algebraic expression in which variable are involved with only non-negative integral exponents are called polynomial. Now, various term you are very familiar about that: constant, variable, degree of polynomial, monic polynomial. So let's get start. That is, you know very well. Today, you see, discuss geometrical meaning of zeros of polynomial. We have seen that a polynomial takes different values for different values of the variable. If you see in the variable, it's obviously indicate us to it has a different values. Consider the example px equal to 2x minus 4. Here it is, you see px equal to 2x minus 4. We can have the different values as follows. Suppose you are putting 1 in x. So you can see here 2 into 1 minus 4 equal to 2 minus 4 equal to minus 2. You are able to solve it. So you see, same as you see one by one you put the value, we get the px value, right? So when we put 1 we get minus 2, when we put 2 in the place of x we get 0, when we put 3 in the place of x we get 2, that is px, and when we put 0 we get minus 4. When we put minus 1 we get px equal to minus 6. When we put 1 by 2 we get minus 3. By taking the values of the variable x and the corresponding values of the polynomial px as ordered pair, we can plot the points on a Cartesian coordinate system. You know very well, in class 8, 9 you have learned Cartesian coordinate system. By joining such points corresponding to the given polynomial, we get the graph of the given polynomial, right? And you know very well, and you are very familiar about graph, how to plot the points on the graph, right? So next you see, next slide, the different order the pairs corresponding to the polynomial. We have a polynomial 2x minus 4 are 1 comma minus 2. We can write like this one. This is open bracket, then we put 1 and minus 2. Why it's called order? So first value is related to x and second value related to y. Like this we can write here etc, and we take the graph paper or graph copy, whatever you are feel connected. Let us see the graph of the above polynomial. You see here this point, this point, this point, this point, all the values which we have taken to get the values of px. Like this we can plot on the graph. You see, it is a straight line, right? No any curve over here. So note that the graph of the given first degree polynomial 2x minus 4, x power is 1, so it is a first degree polynomial, is a straight line, and hence the name linear polynomial. When we get a straight line, we can give the name that polynomial is linear polynomial, and it's linear polynomial representing a line, right? It is the points which required to be keep in mind. The zero of this polynomial is x equal to 2, which is the x coordinate of the point where the line meets the x-axis. Again, you see this slide. Here is the 2. You see here. That's why the other points we discuss here. X equal to 2, which is the x coordinate of the point where the line meets the x-axis. This is because of the fact that the value of the polynomial is taken as the y coordinate of each point, and the y coordinate of a point on the x-axis is 0. Means this one move here, right? So it is x coordinate. You can write here, you can assume like it is a fact, but it's not move, so its point is here. That means it has a y coordinate, but it's on the x-axis, so y is 0 and x is 2. In general, x coordinate of the point where the graph of a polynomial meets x-axis is the 0 of the polynomial. That means all the content, all the things indicate us when the graph line meet at a point on x-axis. There is no coordinate of y. It's called 0 of the polynomial. Clear? I think that, I hope that you understand these things. X-axis touch the, when we are drawing the graph, it touch the x-axis, that is a 0 of the polynomial. Now let's see the next slide. In the same way, we can plot the graph of quadratic polynomial. You know, its degree is 2. For example, here you see px equal to x square minus 4. One by one you take the values and we get the px value here. Sir, x value we see and px equal to that. In the upper class, you know, it can be right. Suppose px equal to x square minus 4 and px we write y-axis. In the function you can understand in the upper class why we write this one, right? So let's next. The corresponding points are 1 minus 3 minus 1 comma minus 3. It is written in order pair. When you are putting the two values in under the small bracket, that is called as order pair, right? We can get the graph one by one. You plot this one here. This one is starting here, like this one. This point here touching the y-axis. Now this is point, and this one like this one. That's here also put touching the x-axis here like this one. This graph, when we draw this graph, you see that one point and one point. So someone will ask you, what is the zeros of this polynomial? You easily tell that two polynomial. No, two zero of the given polynomial. Hence, we can see that there are two points where the graph meets the x-axis, and hence the zeros of the polynomial are x equal to 2 and minus 2. Thus, a quadratic polynomial can have at most two zeros, right? Note the shape of the graph of quadratic polynomial. You see that like and you like here again is a curve known as parabola. Which can be open upward, right, or opened downward. It is a parabola. We call it this type of the shape when we plot the points on the graph paper and to get the zeros, and it's formed like this shape, that is called parabola of quadratic polynomial or given polynomials. The number of zeros will be the number of points where the graph meets the x-axis. The number of zeros will be the number of points where the graph meets the x-axis, and the zeros are the x-coordinates of the points where the graph meets the x-axis. This point is very, very important to be keep in mind. Go to the next slide. You see here. In fact, for any quadratic polynomial, x squared plus bx plus ca is not equal to 0, you know very well. The graph of the corresponding equation, whatever you call it, y equal to ax squared plus bx plus c. I have said in the previous slide that y. We can write for px equal to y, right? Px indicating y coordinate. Has one of the two shapes either open upward like this one or open downward like this one, depending upon on which things it is depend. That two shapes open downward, open upward, depending on the whether a is greater than 0 or a is less than 0. These curves are called parabolas. Understand? If you see on the graph, it is forming like this of shape, that is called parabola. Now let's see the next slide. Here, shape of the graph y equal to ax square bx plus c. Can we write y equal to like this one? Px equal to ax square bx plus c. Yes, we can write. Here the graph cuts x-axis at two distinct points. You see here A and A dash. You can name it. You know very well how to name the point. It is used by the capital letter to indicate the position of any object. You know very well about that. The two zeros of the quadratic polynomial, like you can say A dash. So A and A dash. You see this is downward open. The second one upward open, right? So it is called parabola. If this curve, you see these two distinct points cut this x-axis, so it's zeros is two zeros. Here is written two zeros of the quadratic polynomial. Why this one showing here to make understand that quadratic polynomial. Someone will be asked verbally that what is the zeros of the quadratic polynomial. Without any hesitation, you can say two zeros of the quadratic polynomial. Now next slide you see again. Here also the graph cuts the x-axis at exactly one point. It is touching here, touching, right? You can see here is this one touching. that is A, and here also it is touching this one, this point. So you can say by any confusion, it has a 1 0. You see, here the graph cuts the x-axis at exactly 1 point, that is at two coincident points. So the 2 points A and A dash of case 1 coincide here to become 1 point. A. The x coordinate of A is only 0 of the or 0 for the quadratic polynomial. The x coordinate of A is the only 0 for the quadratic polynomial ax plus bx plus c in this case. In one case you see two zeros. Now the next slide you can see the case 3. Here the graph is either completely above the x-axis or completely below the x-axis. This point, this graph is, this curve not touching x-axis. So what can we say about that? Zeros of the polynomial equal to 0. No any point is touching the x-axis. It is a condition of that to tell that how many zeros over there. So that one no any curve are touching the point or cutting the x-axis or intersecting the x-axis, whatever you have to fill as you on you can understand, but it touch the point or intersect the points on the x-axis, then you can calculate it 1 0 2 0. You can see that according to the graph. If you will practice more and you can understand this one, so many graphs given in your book. So can you say conclude it? The quadratic polynomial x is square plus bx plus c has no 0 in this case. Next slide you can see here. A quadratic polynomial can have either two distinct 0 or two equal 0. That is 1 0 or no 0. This also means that a polynomial of degree 2 has at most two zeros. Means quadratic polynomial has at most two zeros. Otherwise it will no 0, it will 1 0. It is the based on the case. Which type of quadratic polynomial given? Right? I hope that my dear learners, you are understanding these things. The next slide we can discuss for that. Cubic polynomial. Cubic polynomial, you know, you are very familiar about that. A polynomial has 3 degree. Can you say? A polynomial of degree 3 is called a cubic polynomial. It is of form, you know very well. Here is the x cube minus 4x. Consider on that, and one by one you can put the value, you get this table, and this one what? It is a order pair. First is x for x-axis and second is y, here written 0, that is for y. After getting this table, you have a, I think that you have a graph paper and you are able to plot on that. You see there, after completion of this one, you see graph is moving like this one, 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 this one. So you can see here, this point is touching this one. This is, this also, this also. When after plotting the points, you can join the points, you get like this one shape. Right? It is n type. You can see n type. How can we write n like this one? There are at most 3 zeros for any cubic polynomial, right? 3 zeros at most. In other words, any polynomial of degree 3 can have at most 3 degrees, 3 zeros. For quadratic 2, for cubic 3, for linear 1. It is the points which required to keep in mind. So I hope that up to this one you have understand. One by one we have discussed this one in this session for linear polynomial, quadratic polynomial and cubic polynomial dot means degree of the polynomial at most determine the zeros as you seen in this session. So now come to the next slide. If we have, what is the remark you see? In general, given a polynomial px of degree n, suppose you have a degree n of the polynomial, the graph y of y equal to px intersects x-axis at most n point. Yes, sir, we can think. No, you must be think. According to the degree, where the zeros will be there. So we have a endpoints intersecting on the x-axis, that is a polynomial px of degree n has at most n0. A polynomial px of degree n has at most n0. I hope that, my dear learners, you are understanding the things, and this session will be helpful to you and very close your board examination. I ensure you 1 to 2 marks will be come from the zeros. I ensure you 1 or 2 marks you can easily get from this session. If you practice it, you watch this one by one. When you have to get the information from this session or by this, I hope that you get 2 marks on the zeros of the polynomial. Have a nice day to all of you, my dear learners. Thank you.